Hold on to your seats, stargazers. 4 colossal coronal mass ejections are zooming straight at Earth, and they're gearing up to unleash some truly breathtaking northern lights in the coming days. This isn't just any solar show. It's a reminder of the sun's wild side, capable of turning our night skies into a canvas of vibrant colors. But here's where it gets exciting. These storms could light up regions far from the poles, sparking joy for sky watchers everywhere. And this is the part most people miss. These eruptions aren't isolated. They're clustered together, potentially stacking their effects for an even more spectacular display. Imagine the sun, our fiery neighbor in the cosmos, erupting with bursts of magnetized plasma known as coronal mass ejections, or CMEs for short. These aren't tiny sparks. They're massive clouds of charged particles that can travel millions of miles, slamming into Earth's magnetic field and triggering those mesmerizing auroras. For beginners diving into space weather, think of it like this. CMEs are like solar tsunamis, and our planet's magnetic shield acts as a barrier, channeling those particles toward the poles where they collide with air molecules, painting the sky in greens, reds, and purples. A great example, during the Carrington event of 1859, a massive CME caused auroras so bright that people in Hawaii could read newspapers by their glow at midnight, proving just how powerful these events can be. In this case, the action stems from sunspot region AR 4246, a sprawling and magnetically tangled area on the sun's surface that's been unusually active lately. Between October 11th and 13th, it fired off these 4 CMEs, and experts from the National Oceanic and Atmospheric Administration's NOAA Space Weather Prediction Center predict they'll arrive here from October 15 through 17. The peak intensity looks to hit late on October 15 and into October 16, potentially kicking off geomagnetic storms rated at G1, the lowest rung on NOAA's 5-level scale for space weather disturbances. While G1 is considered minor, it's no joke. It can still whip up stunning aurora displays in high-latitude spots like northern Michigan or Maine, and might even cause slight wobbles in power grids or tiny hiccups for satellites. And here's a teaser. These effects could linger for days, keeping the excitement alive. Space weather physicist Tamitha Skov, who shares her insights on Patreon, breaks it down perfectly. NOAA's models indicate the first storm might strike early to midday on October 14 in UTC time, with storms 2 through 4 following from midday on October 15. We could feel their impacts until early October 17, barring any additional solar surprises. She even posted an annotated NASA model visualizing these 4 eruptions charging our way. Skov notes that the initial CME might just cause a gentle ripple, but the next 3 are pancaked so closely that their combined arrival could amplify the whole ordeal, creating a chain reaction of geomagnetic activity. Both NOAA and the UK's Met Office agree that October 16 will likely be the star of the show, with the overlapping impacts possibly sparking those G1 storms. Picture clear skies over northern Scotland, Canada, or northern U.S. states like Minnesota, erupting in auroral splendor. Assuming the sun's magnetic orientation plays nice and points favorably toward us. To clarify for newcomers, the sun's magnetic field has a north and south, much like Earth's, and if they're misaligned, the storm's punch might weaken. This week's solar buzz has been intense, with AR 4246 churning out M-class flares, mid-level on the flare scale, from C to X, including an M2.7 blast on October 13 tied to one of these CMEs. But here's where it gets controversial. While aurora hunters are thrilled by these predictions, some skeptics argue that overhyped space weather forecasts might downplay real risks, like potential disruptions to modern tech-dependent lives. Is the allure of the northern lights worth the underlying threats to our power grids and satellites, or does this just highlight how vulnerable we are to the sun's whims? And this is the part that sparks debate. Could increasing solar activity be linked to broader climate patterns, Or is it merely a natural cycle we're only now noticing more due to better tech? What if these minor G1 storms mask bigger ones on the horizon, forcing us to rethink our reliance on space-based services? For those new to this, CMEs originate from the sun's corona, its outer atmosphere, where magnetic loops snap and release stored energy. When they interact with Earth's magnetosphere, they can compress it, allowing particles to rain down and create auroras. The upcoming batch is moderate in strength, but their tight grouping makes them a hot topic for enthusiasts. As solar activity ramps up, it's a fantastic chance to learn about our star's temperament. Get your binoculars ready and your camera set. We might be treated to an unforgettable light show. Join the conversation in our space forums to discuss the latest missions, night sky events, and more. Got a news tip, correction, or thought on this? Drop us a line at community@space.com. Daisy Dobrajek has been with Space.com since February 2022, after stints at our sister publication All About Space magazine as a writer. Her journey into journalism started with an internship at BBC Sky at Night magazine and hands-on experience at the National Space Centre in Leicester, UK, where she loved sharing the wonders of space science with the public. In 2021, she earned a PhD in plant physiology, paired with a master's in environmental science, and now calls Nottingham, UK home. Daisy's heart belongs to the cosmos, especially solar phenomena and space weather, and she's all in on astrotourism. Nothing beats chasing those northern lights.